I like to think of algebra as the part of math where you start doing arithmetic with unknown values. And so instead of evaluating with known values like 2 plus 2 equals 4, you'll learn how to find missing values step by step using certain rules and properties, which will hopefully become second nature to you. Now, this will assume that you have a fair understanding of basic arithmetic, but even if you think you're rusty, you should be able to get the feel for things as you progress through this segment. So to start, in regular arithmetic, you work with numbers you already know the value of. So 2, 5, and 10. But it's not always this easy, because in algebra, you introduce symbols like x, y, and z. And these symbols can take on different values. So x might turn out to be 2, but in another case, x might turn out to be 10, and y might turn out to be 5, and z might turn out to be 5, and so on. So these values are not known. So let's take, for example, x plus 3, which equals 7. Here, x is not a symbol you just guess randomly. It represents a specific number that makes the equation true. So in this case, x would have to be 4, since only 4 plus 3 equals 7. So the goal of algebra is to find the value of the unknown that makes a statement correct. It would be good to quickly explain a few key terms before we approach our next coming videos. Those key terms being expressions, simplification, equations, variables, evaluate, and solve. So now an expression in standard algebra is any finite combination of numbers like 2, 3, and 4, or variables like x and y, and standard arithmetic operations like plus, minus, multiply, and divide. And altogether, a certain value. So for example, 3x plus 5 is an expression, and so is 2 minus 1. Now, simplification transforms said expressions into an equivalent expression that is some smaller combination, or even sometimes easier to look at. So for example, let's say we have 36 over 8. Now, this is an expression, but we can look for some simpler expression to work with that mathematicians may prefer, of which being 9 over 2. So we'd say that 9 over 2 is a simplification of 36 over 8. Next is an equation, which is just some statement asserting equality between two expressions, as in the name equation. Now for variables, a variable stands for some value that can take multiple possible values. Most commonly numbers like 1, 2, and 3. And now note that some expressions and equations can contain variables, to which their value that they assert will depend on what the value of the variable is, out of all possible values that it can take. So for example, what x plus 5 equals depends on what x is. So if x equals 5, then we know that x plus 5 equals 10, since 5 plus 5 equals 10. To evaluate an expression means to compute its numerical value by performing the indicated operations after substituting given values if variables are given. Like for example, 3x squared plus 2x, where x equals 4. So what we're looking to do here is substitute 4 for x. So this would become 4 squared plus 2, 4. And then we can look to simplify it from there. So that would become 3 times 16 plus 8. And that all comes to be 56. And lastly, to solve an equation means to find all the possible values of the variables or variable that make the equation true. So for example, let's say we have 2x plus 3, which equals 11. That just transposes to 2x equals 8, and then x equals 8 over 2, which is just 4. So now, without given a value for x at the beginning, we were able to deduce that x equals 4 given the known values in the equation, where x is the only unknown value. You may not know it, but algebra exists in many real-world problems involving missing information. Take, for example, you might know the total cost of items you bought in a grocery store, but you don't recall how many items you bought. Or you might know the distance you drove and the speed you were going at, but you might not recall the time it took to get there. However, all these unknown values can be found using algebra. So through this segment, we will first take a look at some preliminaries that I believe are absolutely essential to being successful in an algebra class. And then we'll move on to solving all types of equations and inequalities, along with graphing and functions, which we'll get to in due time. First starting with integer exponents.